So for section 2.2, we're going to look at frequency distribution. I'm going to go ahead and skip through kind of the beginning of this. You can download this and kind of read through it, but obviously we're going to be classifying or grouping the data, okay? You need to kind of figure out at some point, because I'll just give you lists of data and you need to figure out a logical way of grouping them. Depending on the technology, they may not do that very logically, so they may group it by 2.3s or by 1.7 or by, because your technology just creates so many groups, and so it's not very smart about it. So what we really want to do is kind of look at this and go, okay, what's our maximum number on here? So I see, looks like a 428. Anything bigger than that? Let's go ahead and take the 428. All right, call that our max. We'll take the lowest number. I see 363. I think that might be our lowest. So 363. That would be our minimum. And if I take the range and I divide it by the number of groups that we need or want, it will kind of give me an approximation for a minimum size of the groups. So the range is going to be the max minus the min. So 428 minus 363. So what is that, 65? Right? And we want there to be at least 5 groups. If we don't have at least 5 groups, we're not really spreading out the data. So if I take that range and I divide it by 5, then basically if I have size 13, okay, then that would basically be the size that would give me that exact number of groups. Okay, if I make the groups, so this would be the group size. Now I'm not going to go by 13s, that's not logical. I'm not going to go from 363 to 376 to 380, not whatever, 389, just go on and on by 13s. What we normally do is we group by 10s, by 5s, by even numbers. So sometimes we'll go by 2s, but don't do any crazy decimals. And that's where you have to be smarter than the technology, because a lot of times the technology will basically set those groups to be decimals and just kind of get those minimum size. So, but if I do 13, right, that's going to give me 5 equal groups. So if I do a smaller size than that, so I guess this would be kind of another way, but this would be the largest size of a group that we can do. I need a size that's a little smaller than this. So they go, well, what if we went by, well, 10s? Well, then I would end up with, well, like 6.5 groups, right? Well, or 7 groups basically. But the idea is that we need our size to be at most 13. Anything larger than this is not going to give us enough groups. Anyway, that's a little extra because right now all they're doing is they're basically already setting this aside and they're telling us, look, from 360 to 369, right? How large is that group? A lot of people go, well, yeah, subtract them and you get 9. I disagree. 0 through 9 is not 9 numbers. See if you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That has 10 numbers in the group. Okay? So what we're going to do is we're going to go through and we're going to kind of tally these and go through and figure out how many we have. So if I take the 423, I go to 420 to 429, and I put a little tally mark there. 369 goes right here, put a tally. 387, right here. 411, right here. 393, right here. 394, 371, 377, 389, 409, 392, 408, 431, 401, 363, 391, 405, 382, 400. I'm going to cross that for a 5 there. 381, 399, 415, 428, I messed up there. The max isn't 428, is it? What was it? 430 something. Oh man. See, and that's where I'm always going to make mistakes like that. What was it? 430 something. 423. I am just not seeing it. 431. So let's go back to this. And yeah, you may have been screaming at your calculator or your screen earlier. But this is one of those things that I make mistakes. So 431 minus 363. How about, what is that, 68? And 68 divided by 5 would be 13.6. And we're not going to set the group size to 13.6. That's kind of ridiculous. So what we do is we set the group size a little smaller so that we have more groups. We'll have at least 5 groups. Okay? All right, so fixed that. Sorry about that. 422, 396, 372, 410, 419, 386, and 390. Okay, so now what we can do is we can figure out what is our frequencies for these ones. Well, from 360 to 369, there are 2 numbers. There's 3, here there's 5, 7, 5, 4, 3, 1, for a grand total of 10, 17, 22, 26, looks like 30. This is a good time to check. They said that we were looking at what? 30 batteries. This adds up to 30. That's a good sign. That is basically our sample size. Okay. Okay, so that's something I'm going to expect you to be able to do. If I give you a list, you should be able to make a frequency histogram. That's what this is called, a frequency, not histogram, frequency distribution. It's a distribution or a table where I have the classes, that's what these are, is the classes, and I have the frequencies with that. Sometimes I'll give you those classes, sometimes I won't. So I may give you a list of data like on a quiz or a test, and I'll say, make a frequency distribution. You'll have to figure out a logical class size. I'm not going to go super crazy on this, but probably, like I said, 10s or 5s, okay? You can do evens and all that. You can do all kinds of crazy stuff that we're not in there. We're not trying to get to that point, okay? Anyway, so you'll need to be able to do this, and this is something that's kind of interesting to know as far as just kind of getting into what you can do with statistics. But everything down here is basically going to be homework only. I don't know why that's moving, but homework only. So don't plan on me, going, oh my gosh, you need to, I'm going to ask you for a lower class limit on the test. Go through it, get used to that vocabulary a little bit. They do some interesting things with it in the future, but this will not be tested. So what the lower class limit is basically we do a half step below the lowest number in a class. So here I have 360. Well, what if my minutes weren't exactly minutes? What if I had, 359.3? 359.4, 359.5. At what point would we include that number with the 360? Well, basically what we do is we go a half step below. And since all of these are kind of going by minutes, by whole numbers, then a half step below 360 would be 359.5. That's actually the hardest lowest class limit to get. See, the lowest class limit on the next one, well, it's 370, so a half step below that would be 369.5. It's also going to be right in the middle of, if you have an upper class here and a lower class here, an upper number and a lower number, it'll be right in the middle of those. That's another way of finding that step. So the middle of 369 and 370 would be 369.5. The next one here would be 379.5. And so on and so forth. So those are the lower class limits. We include, any of those numbers get included in that tally mark. The upper class limits are basically going to be the upper numbers, kind of the same idea as a half step. So this will be a half step above the highest number in a class. So the highest number in the first class is 369. So the upper class limit would be the 369.5. See, that's also half a step below the next lowest number. It's half a step above the highest number in that group. So the second group would be 379, so a half step above that. Then 389.5, and so on and so forth, till the very last one would be what? 439.5. So what do we do with these lower class limits and upper class limits? Well, we figure out what numbers do I put in the first class. Well, I can't include 369.5 in both of these. So basically our class boundaries are going to be the lower class limit less than or equal to some number is less than the upper class limit. Meaning our first boundary is going to be from lower class limit 359.5 up to the upper class limit 369.5. The next boundary would be at 369.5 up to 379.5. Well, I said we can't keep that 369 in both, right? Well, notice the lower bound is the one that has the equal to. So the actual number 369.5 would go in the second class. So we go up to that number in the first class, and it's the beginning of the second class. So the next one would be 379.5 included on the third class up to 389.5. So that's one way of writing it. You can also do this, sometimes they'll do this in set notation, where you would do the lower class, comma, the upper class, with parentheses. So you could put 359.5 in brackets, 369.5 in parentheses, 369.5 in brackets, 379.5 in parentheses. So depending on your comfort, either of those would be fine. I'm pretty sure they use the inequalities in the homework, but either way, both are fine. So basically, when I look at this first class, right, what are the limits? Well, this one goes from 359.5, oops, included, and up to but not including 369.5. This one is 369.5, included, up to but not including be 379.5, so on and so forth. So the last one would be what, 429.5 up to 439.5, not including. Okay, so that would be how we would do those limits. Class midpoint, literally just the middle. So you could do the lowest number plus the highest number and divide by 2. So in our first class, the lowest number, 360 to 369. Divide by 2 should be 364.5. It's right in the middle of the two. 360 or 370 is the next to 379. 374. These would be the midpoints. To do the class width, it will either be the difference of consecutive lower numbers or the difference of consecutive higher or highest number in a class. So our first lowest number was 360. Our next lowest number consecutive, the next one was 370. The difference between 370 and 360 is 10 numbers. Or I could go, well, the first highest number is 370. The next highest number is 380. 380 minus 370. There are still 10 numbers. 10 numbers between them. Okay? Once again, not tested, not an A-basket issue, but that will show up in the homework. So don't be too concerned about it. But definitely, if you needed help with it, I'd be happy to help you with those. So now that we have these frequencies, what do we need to be able to do? Is a couple things. First one's called relative frequency. What the relative frequency is, says what is the frequency relative to the total? So it's the frequency relative to the total. Or basically the frequency divided by the total. So we have the frequency, we have the total. So this would be 2 over 30. This would be 3 over 30, 5 over 30. And we do need to be able to put those as decimals. So I know that ain't going to be pretty, but the idea is that we want this as like a percentage a lot of times. So 2 out of 30 would be what would it be? 0.06, I think. Let me double check that. 2 out of 30. Yeah, 0.0666, so 0.067 due to 3 decimal places. Next one, 3 out of 30 would be 0.10. 5 out of 30. I think we have some technology for that. 5 out of 30. 0.1667. 7 out of 30. 5 out of 30. 4 out of 30. 3 out of 30. And 1 out of 30. Alright, so let's see. This would be 0.033. This would be 0.1. This would be, let's see, we didn't do that one. 4 out of 30. I'll get to that one in a minute. I'll do these ones. So 7 out of 30 would be I killed myself. 0.2333. Only 3 decimal places, it's fine. 5 out of 30. And 4 out of 30. I think those are the last ones we needed. So the 4 out of 30 and 5 out of 30. All right. And if I added all those up, the relative frequencies, basically this is a way of saying a percentage as a decimal So before we go on, I just want to make sure we know real quick the relative frequency, frequency relative to the total. We said it's basically either a percentage or we sometimes write it percent as a decimal. Be careful. Currently, I have them all as decimals. If you wanted to write this as 6.7%, that'd be fine. This, if I move it twice, would be what, 10%, 16.7%, 23.3%, 16.7. So you would basically, you can write it as a percentage. It's not a problem. And there are going to be times where we want it as a percentage. But more often than not, I'll have you write this as a decimal. But you only write that percentage symbol when it's a percent. So don't write 0.1% when it's 10%. Okay, so be very careful with that. The other thing is if we were to add up all of these, so if we were to total all these, if I total up all these fractions, they would add up to 30 out of 30, which is 1. If I was to total up all these decimals, they should total to 100%, or as a decimal, they total to 1. Maybe. All right, so sorry about the technical problems here. So it should total to 1, and then this as a percentage should total to 100%. But be careful, because you actually want to check this. If I add all those up, and I have that already put in my calculator, but if I take all those decimals, I did, and I put them in my calculator, if I add all of those, we rounded all of these. So it might not total exactly 1. This time it does. So I'm like, okay, I feel good about that. But what if it was like 1.01, right? 1.02. That's okay. So be careful. Be careful for any round off error. That's okay to have some round off error. So if this was 1.01, this was 101%, we don't freak out about that. That doesn't mean we made a mistake. It just means we rounded everything, and so a couple things rounded up, and it made it total a little more than 1. It should total to 1. It should total to 100%, but be careful for round off error. That's why we're generally not going to round our answers till we get to the very end of the question. Okay. All right, we have two more types, not terribly hard. Cumulative frequency is where we accumulate, so we add the frequencies. Okay, so for my first frequency, it was 2. So the cumulative frequency, if we add up to this point, would be 2. Well, the next one had a frequency of 3. So to accumulate, to add to that point, we would add 2 plus 3 is 5. You add to that point. The next one would be 2 plus 3 plus 5. The 2 plus 3, we're accumulating all the frequencies up to that point. So 5 plus 5 is 10. The next one will be the previous frequency. I'll just say, instead of writing 2 plus 3 plus 5, those all total to 10. So it would be 10 plus, what was the frequency for the 400? Well, 5. So 10 plus 5 is 15. What we're doing is we are adding all the frequencies up to that number. How many numbers were less than 400? Well, there were 10 numbers plus the 5 in this group. So that we add all of the frequencies. How many were less than the 410 there? Well, the 410, I think I messed up on the number. That should have been a 7. So feel free to scream at your computer and all that. This should have been 10 plus 7. Let's see if I can fix that. Makes that about 17. So now, basically, the next one had 5. So it'll be 17 plus the 5 is 22. The next one should be 22 plus, looks like 4. 26 plus, looks like 26 plus 3. And last, 29 plus, how many were in that last category? makes a total. Now the cumulative frequency should total at the end. This should be the total. We added everything up to the highest point, so it should total to the total. Last but not least, cumulative relative frequency. Cumulative, we already know means add. Relative, we already know. We did in the last one, we are going to add percentages. So we have two ways of doing this. We already have them all added, so we can take all those things that are added and turn them into percentages. So the first one would be 2 out of 30. The next one would be 5 out of 30. So we could take the one that's added and turn it into percentages, or in the previous table we had all the percentages, we could actually add the percentages. Either way, since we already have these totals, I'm just going to put each one over the total. And 30 out of 30. This should total 30 out of 30 should total to 1. Now be careful, because if you did this 2 out of 30, that should be what we had before, which was the 0.067. The next one, we add the 5 out of 30, which is basically this 0.067 plus 0.1. I can add these percentages, 0.167. Really, I'm adding decimals. I don't want to say that wrong. The next one, we're going to add another 5 and get 10 out of 30. Should be 0.333. Now notice this. If I was to add those, right, I would have basically ended up with 0.334. So be careful of that round off error. Okay. So anyway, we can keep going on these. The easiest way, I think, is once you have the cumulative frequencies, once you've added the frequencies, just put each one over the total. So I would just take the, for this one, I would take the cumulative frequencies and divide them by the total, which would be n. Okay, our sample size, or our total. Okay, so let's go ahead and continue that. 17 out of 30. .566, how about 7? So 0.567. 22 out of 30. .733. 26 out of 30. 0.867. 29 out of 30. 0.967. And then 30 out of 30 or 1. So those are the main graphs that you're going to be dealing with, or I guess at this point, frequency distributions. The next chapter is not bad. We're just going to make histograms out of these. So we're basically going to take all of these categories, we're going to graph them on the x-axis, and then we're going to take either the frequency, the relative frequency, the cumulative frequency, or the cumulative relative frequency. We're going to put these on the y-axis, and we're going to create kind of a graph. Each of these is going to represent a bar, so we're going to have a histogram for that. So it's really not terribly difficult. I will have a lecture on it still, but it's just going to build off this data. See if there's anything else we need to talk about. If you do notice a mistake that I make in any of these videos, please feel free to comment in our class site. I can make some corrections to these, but I may just add a note and say, hey, there was an error here, thanks for catching it. So please, because when I do this in a regular class, you'll see me make mistakes. So I'm sure as I'm making these videos, you'll see me make mistakes. Anyway, the last thing we want to talk about is kind of a general introduction to a normal distribution. What a normal distribution does is the frequencies start low, increase to a high frequency, and then kind of decrease. We can see this numerically. If I look at this question, let's see. this data was relatively normal. It started off low, 2, 3, 5. It reached a peak, kind of a highest point around the center, and then it got lower and lower and lower. We'll see this more in our next one, but basically visually, what we have is we start with, these are our categories. This is our, well, it'll either be frequency or relative frequency or whatnot, but it started low, it got high, it reached a peak, and then it starts going back down. Tends to be symmetric. Another word for that, we'll say it's roughly bell-shaped, or they'll say mound-shaped sometimes, like a hill. But the idea is that if I were to draw a curve over this, it would be roughly symmetric and mound-shaped, or like I said, bell-shaped is probably what we use more often. Okay, so that's just a kind of general introduction. They're going to have you looking at data and go, is it roughly normal? Students tend to be a little more critical than they need to be on this. If it is kind of within this shape overall, we call it relatively normal. It doesn't have to be perfectly normal for us to say, hey, look, this data looks pretty normal. Okay, so that's it for this section. Should have been a pretty easy one. Let's keep going.